2.5 clearing decimals. This basically does the same thing as clearing fractions, where if we have decimals in the problem, we get rid of them at the beginning so that we don't have to deal with them for the rest of them. I will say clearing decimals not as important as clearing fractions. Fractions have more problems that come with them, but decimals are usually fairly easy to handle. But I'll still show you how to do it just in case you want to do it that way. Um, but it's just a matter of moving the decimal places. Um, yeah, so let's start with the example they give us, 2.5a on page 62. So the question, we got our problem here. As we see, we got multiple decimal points in the problem. So just like with the fraction, well, not just like, but the question we want to ask is, how many decimal places do we have? So we have one decimal place here, we got one here, and we got one here. So the most decimal places we have is just one. So if you recall, how do we move the decimal over one space? What do we multiply by? Multiply by 10. Multiplication by 10 will move our decimal to the right one. So just like when we did clearing fractions, we'll rewrite each side. We know that we need to multiply by 10, so that's what's going to go outside of our parentheses. Oops. Wow, look at that save. Almost. That's no decimal. Great. All right, so 10 multiplied by 0.2, it's just the same as moving the decimal over once. 0.2 gives, moving the decimal gives us 2x. 3.2, move the decimal over once, gives us 32, and then 1.8, moving the decimal once, gives us 18. That's great. Solve it like a normal algebra. Opposite of adding by 32, subtraction by 32. What we do to one side, we'll do to the other. Cancel, we're left with 2x. 18 minus 32 gives us negative 14. X divided by 2, or divided by 2, what we do to one side, we'll do to the other. We got x. 14 divided by 2 is 7. We have 1 negative, which means it's negative. X equals negative 7. Now, that's how we would do it. Now, just the shortcut way is how many decimals, what's the most number of decimal places we have? We have 1. So let's go ahead and just rewrite it. Move the decimal over once for all these. 2x plus 32 equals 18. And that way we can save the extra step where we have to distribute by 10. And it's just, we're doing the same thing. We just take our shortcut. Let's do problem 2.5c. 1.3x plus 2.04 equals 7.24. Just move the decimal. What's the most number of decimals we got to move? We got 1 here, we got 2 here, we got 2 here. So let's move everything over by 2. 1, 2, 1, 2, 1, 2. What do we got? We got the decimal's gone. So we got 130x plus 204 equals 724. Now, we're kind of stuck in the same situation. These things are exactly the same. It's just this one's doesn't got decimals and this one does. These are smaller to work with, these are bigger to work with, but at the same time, you know, 240 divided by 20 is the same as 24 divided by 2. That's basically the same concept we got going on here. But if it's easier for you to work without decimals, by all means, use this process. If not, just go ahead and solve it the normal way. It's not going to change anything about the problem. And I won't even so let's just see what it looks like. Minus 204, minus 204. This gives us 130x. This is probably going to give us I don't know. What is it going to give us? 520? Oh, 1352. Recognize the deck of cards when you see it. X equals 4. Yeah, so you can use it or you cannot. I'm not going to do any more examples of that because it's silly to me, but you can use it if you want. Okay, bye.